We're supposed to drag the blue point to a location on the coordinate plane so that vector v has a magnitude of 17 and a direction of 28.07 degrees. So that sounds like some trig we could do here. And it says relative to the x-axis too. So that means when we make our angle, we need to make an angle of 28.07 degrees. Magnitude of 7 means that this line here, from the initial point, let's say at the origin, initial points at the origin, it's supposed to be 7 in direction, and then 28.07 is supposed to be our degrees. So let's see, what do we need for this vector? We need both the x and y coordinates here, right? We need to know how high up it is on the y-axis, how far across it is on the x-axis. So let's solve for y first. The opposite, and then this would be the hypotenuse over here. So we got sine 28.07 equals the opposite divided by the hypotenuse. Calculators in degrees, 28.07, trig sine. And then to solve that equation to get y by itself, I'm just going to multiply both sides by 17. So we get roughly 8, which is probably what Newton designed that problem to look like. And then to get x, that's the adjacent divided by the hypotenuse. So we're doing cosine 28.07 equals the adjacent divided by the hypotenuse. So 28.07 cosine multiplied by 17. And that gives us 15 roughly. So 15 on the x, 8 on the y should be this vector. 15 on the x, 8 on the y. Vector v is 3 units long, makes an angle of 262 degrees with the positive x-axis. So here's the positive x-axis. 262 degrees, there's 90, 180, right around here. So our vector goes down here, bolding, putting the vector in bold here. It's 3 units long, and it's 262 degrees. So we're supposed to find the component form of the vector. So you could draw yourself a right triangle. I guess it really doesn't matter where you draw it. Usually we draw the right triangle with the x-axis, so we'll stick with that, but you could still do it without it. Now if this is 262 degrees, this is 180, so what's left over for this angle in here? 82 degrees for this angle, which is what we usually call the reference angle when we're doing a bunch of stuff in our trig class. And we know this is 3. So if we can find the x, the adjacent, and the opposite, we'll have our x and y. We'll be able to talk about the x and y components of the vector. So to find the opposite, that's sine of 82 equals the opposite divided by the hypotenuse. So 82, we're going to hit sine in our calculator, and then multiply it by 3. I don't know about this. 2.97? Yeah, okay, they have that as an option. So y is going to be 2.97, and it's going to be negative because, look, we're going down on the y-axis. So check your signs at the end. Y needs to be negative 2.97, so it's one of these two. And now the x is also negative. The x would be the adjacent. So cosine of 82 is the adjacent divided by the hypotenuse. So 0.417 roughly. X is negative 0.418. We'll round. Oh, so this is our correct option. That's the closest one, right? Negative 0.42. And again, it's negative because you're going in the negative direction on the x-axis there.